Hello everyone, welcome back to another video on my YouTube channel. Today we are looking at another problem from the blind 75 list of problems, and this problem is called remove nth node from end of list. In this problem we are given a linked list, and in this linked list we are also given a value of n, in in this case which is 2, and we are supposed to remove the nth node from the end of the list. So in this linked list we are supposed to remove second node from the end of the list, which will be 4. So once 4 is removed, this will be our resulted list. Now, how can we find the nth node from the end of the list? The first thing we can do is, first of all, find the length of the whole list. So this has 5 nodes, so that will be one pass. So once we find the length, which will be 5, this will be O of n. Once we have the length, what we'll do? We need to reach the third node and change thirds next to thirds next. That is, remove this node completely and change next to here. So to reach the third node, I will go to the which node? I'll go to the length minus nth node. Length minus nth node. I'll move these many steps to reach here. Okay, so I start with 1, move to 2, move to 3. Now once I reach here, I'll simply change this to 5 and delete this fourth node, and that will end up removing the nth node from the end of the list. But this is a two-pass approach because we are uh, iterating the list twice, and we are given a follow-up that can we do this in one pass? Now, can you think of a solution where we do the same thing in one pass? Now, for the one pass approach, what we can do is take 2 pointers instead of 1, and don't calculate the length initially. So what we'll do is take 1 pointer initially, let's call it first, and move this n plus 1 times to the right. So if I move it n plus 1 times, that is 2 plus 1, 3 times here. So that will be 1, 2, and 3. So once it reaches this node, I moved it n plus 1 times. I'll take another pointer now for called second. And now I'll move both the pointers towards the right until first becomes a null pointer. So I'll move second here. This is gone. First will come out here. Then move once more. So first comes here. And first becomes null and second reaches 3. So our main objective was to get to 3. So at the end of it, where will be my first? First will be here and second will reach here. Now once I have the second pointer at 3, I can conveniently do the same thing that we were doing earlier. Change its next pointer to directly 5 and delete this fourth pointer. So this will be another one pass approach that we can use to solve this problem. Now what would be the time complexity of this? It will be the length of the list, which is, in this case, n is the input value, so let's just call it O of length. And space complexity will be O of 1, as we are not using any extra space. This is time and this is space. Now let's code this one pass solution. Now here I am given a function called remove nth from end. We are given a head node and n as an input. Now what did we discuss initially? We want to take 2 pointers, first and second. So let's do that. And we want to move first how many times? N plus 1 times. So let's take a k, and while k minus minus, I will do first equals to first, next. And once first reaches n plus 1th node, which in this case will be the 4. 1, 2, 3, yes, 4. Then what I'll do is move both first and second. Okay, I'll need to assign it to head initially, so let's do that as well. And while first is not equal to null pointer, I'll move both first and second. So first equals to first next, and second equal to seconds next. Now second has the value, second is pointing to the node before the node which we want to delete. So let's call it, let's node star to delete will be seconds next, and seconds next we can change to seconds next. Then simply delete this to delete node, and at the end just return head. Okay, let's check the edge cases first. So n can be 1 and size as well. So if n is 1, that means I remove the last node, and in last node I'll move 2 times, so I'll reach 3, and k will become 3, and I'll move to 4, second pointer will move to 2, 5 and 3, and null pointer and 4. And 4's next I'll change to 4's next, and I'll delete 5. Okay, so the case where n is 1 is working fine. For n equals to size, let's see if n was 5. I'll move 6 steps. So 1, 2, 3, 4, 5. And now to handle the edge case where the input condition only has one node. So in that case, we can just handle it at the top. So if next is equal to null pointer, that means there is only one node, and n is equal to 1. That means we want to remove that particular node. In that case, we have to return null pointer because we are removing a single node. Now, another thing that I want to handle is when n is equal to the size of the list. For example, in this case, if I wanted to remove the fifth node from the end, that is 1, 2, 3, 4, 5, that is I want to remove this first one. So that I can handle in this case, because if n will be 5 and k will be 6, so I'll have to move 6 steps ahead. So 1, 2, 3, 4, 5 will be null, and I won't be able to move to the 6th step. So in that case, I'll just handle it here. So if first is equal to null pointer, I won't be able to move ahead. So in that case, just break. And I can add a condition that if k is not equal to -1, which will be at the end of this list, if this runs fully, then that means I'll have to remove the first node. So first node removal case. And here, if I have to remove the first node, I'll just return heads next. Another thing that I was doing wrong is deleting this to delete node before uh, before changing the seconds next. So delete should happen after changing the next pointer. So this should move down. First I will change the second next to second next, and then I'll delete the node to be deleted. So for example, in this case I have to delete 4. So what I'm doing is storing this 4 in a to delete variable. Then I'll move 3's next to 4's next. So if I delete 4 beforehand, which I was doing earlier, that will be a problem. So I'll just use this first and then delete this. First node is handled, single node case is handled. Now let's see if this works. Okay, all 3 test cases are working. Let's try submitting it. As you can see, our one pass solution is working. If you have any doubts or queries, feel free to leave comments below. And thank you for watching. See you in the next video.